This lesson is going to be looking at exponential growth and decay. Exponential growth has a formula. It's y equals c times 1 plus r to the t power. And then it tells you on the screen what each variable stands for. The c is what you start with. The 1 is always going to be 1. The r is the rate, which is often most likely a percent. And t is the time. And then 1 plus r is what we refer to as the growth rate. If it was exponential decay, the only difference between the formulas, exponential decay would be y equals c times 1 minus r to the t power. Otherwise, the exact same values for every other thing. So let's take a look at something with exponential growth. The hardest part of this is probably deciding whether it's growth or decay. So we're looking at Maria and having a bank account. When you have a bank account, you put your money in the bank. The bank pays you interest on your money that you put in there because it technically lends it out to people who have loans and whatnot. So it kind of pays you a certain percentage so that it can use your money while you have it stored in the bank. So exponential growth. This is growth because they're paying you interest. So your money is growing or it's increasing. So in order to figure this out, it says find the balance after 4 years. I have my original equation for exponential growth, which is y equals c times 1 plus r to the t power. And then to identify some of the variables, c is what you start with. So that's 600 because Maria started with 600. And then the rate. The rate we talked about being the percent, which is 3.5%. However, we cannot use a percent. You have to have it turned into a decimal. So to make a decimal out of a percent, I have my decimal. It's in my percent already. And to turn it into an actual decimal, I have to move my decimal that's already in my percent 2 times to the left. So I'm going once, twice. So now my decimal is out here. And I have an empty space, and that empty space I have to fill it in with a 0. So the value that I'm using for r, or the rate, is 0.035. And then I have my value of t, and that is 4, because I want to find the balance in the account after 4 years. So in order to simplify the equation, there's only one part that I can simplify. I can simplify this part here, 1 plus 0.035, which is 1.035. So my actual equation for growth would be that equation there. And in order for me to figure out how much would be in the account, I want to take a calculator and I want to put in 600 times 1.035 to the 4th power. And then remember, we are looking at this as if it is money. So money, we always round to the nearest hundredth because there's only 2 decimal places after the decimal in money. So we'd be looking at a balance of $688.51. Sometimes you might be asked to graph the exponential growth function. So you'd have to be able to find the values for the different amounts of years. So I would start at 0 years. 0 years would be the balance she put in there. So my first point would be at 600. Then I would have 1 year, and I would use a calculator, and I would, in my equation that's circled on the screen, I would substitute the t, or the exponent, with the number of years. So I put a 1 in there. And again, with the values being money, I would round each one to the nearest hundredth. And as you can kind of see in the graph on the right, our values here on the x-axis would be our years, and then the value on the y-axis would be our money, or our amount in the account. And as you can see, it's kind of a curve. An exponential function, if you let it graph wide enough, meaning over a number of years, will not look linear. It will end up being a curve because the value increases exponentially fast. Something else to keep in mind when you're looking at an equation for the exponential function is if the value inside your parentheses, your growth rate, if it's greater than 1, you're looking at an exponential growth function because it's becoming more than the original 100% or the 1. If it is less than 1, it is an exponential decay function. So let's take a look at what an exponential decay function might look like. Okay, so this situation says you buy a truck for $15,000. The value of the truck will decrease at a rate of 8% per year. What is the value of the truck after 5 years? So the exponential decay function, we still have the y equals c times 1, but since it's decay, it's minus r to the t power. And then if we identify what we're looking at, our c, our value, the initial he started with of the truck was 15,000. The rate is 8%. And remember, as a decimal, you have to take the percent, which is 8. So I'd have to take my decimal, which should always be at the back if there isn't one, and I move it 2 spaces to the left. So I'm going once, twice, so it becomes here. So then I would have my 0 filled in the blank space, so my decimal would be 0.08. And then t, I want to know the value after 5 years, so my time is t. So if I put those values in an equation, I would have y equals 15,000 times 1 minus 0.08 to the 5th power. And I can always simplify the subtraction problem inside the parentheses, so 1 minus 0.08 is 0.92. So this would be my final equation for the exponential decay. And remember, I'm graphing with, or I'm not graphing, I'm dealing with money. So if I got that on my calculator, my answer for after 5 years, the truck would be worth $9,886.22. So if we're graphing this particular one, again, I would have my years on my x-axis and the value of the truck or the money on my y-axis. And if you notice, again, just like with the exponential growth, the exponential decay is also looking like a curve.